All right, so the rest of our conversation about hashing will refer to the situation where we don't have a perfect hashing scheme. And what do I mean by that? Well, we don't have a scheme where each key hashes to a different index. Why might that be the case? Well, there's many reasons that might be the case. First of all, our hashing function might be such that I can put in two different two different keys, and it will output the same index. Okay, it's not great hashing function, but that could happen. All right, and so a lot of thought has to be put into what this hashing function actually is, and we're not actually going to do that kind of analysis in this class. We're just going to assume, we'll just give you a few hashing functions to play with. Another thing is, we might not actually know. So in Old Westbury's case, the size of that hash table was 1 million. I made that mistake. Sorry about that. I got the question mark. I don't know what I'm doing. I said it was 100,000. It's actually 1 million, which is funny. It's like the person who came up with our database in Old Westbury was Dr. Evil, right? There's never going to be more students than 1 million at this school. Okay, whatever. The other thing is that maybe we don't know what the maximum size is. I mean, we really don't know at Old Westbury, right? There's going to be, at some point, we're going to get past 1 million students who have ever come here and not since the beginning. It's just since they started using 700 numbers. I think they were using a different scheme before then. So I think a student explained this to me once, but I forgot. So, but yeah, so we haven't gotten to 1,700,000 numbers yet, but we had maybe a different scheme before that. So we have gone past 1 million students, I do believe. Maybe, I don't know. Actually, I should check that out. Anyways, so what if we need to, so what if, let's say we only had 10 spaces. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 10 spaces. All right, and let's say we don't have, we could still use the 700 number, but I'm gonna use some, so we don't always have like a nice key, okay? And so sometimes we have to just come up with our own hashing function for these things. How do we come up with our own hashing function for these things? Well, it could be all sorts of things. One thing we might do is I might say, well, we have all these names, right? And so what I'm gonna do is whenever someone comes in and gives me their name, so Sandy Newman. Okay, what I'm gonna do is I'm gonna count up the length of their names. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the length of this is 11. And now I need to somehow get it into I'm gonna store it in an index that relates to that. But I only have numbers between 0 and 9, all right? So the way I'm going to take this and get a number between 0 and 9 is I'm going to say, I'm going to module it by 10. And that will be my hashing function. So I put in 11, and we 11 modulo 10. And modulo, remember, is the remainder function. So if you want to do it the old school way, right, 10 goes into 11 once, 11 minus 10 is 1 with a remainder of 1, and we take that remainder of 1, and that's what ends up coming out, okay? And so we throw Sandy Newman, the great Sandy Newman, okay, into index 1. And we're like, that's the end of that chapter, except some of you are like, wait, hold on, that's hardly gonna solve this problem, Okay, and why is this hardly going to solve this problem? Well, we're going to have more than 10 students, and at some point we're going to have a collision. For example, if Elise Roger 1, 2, 3, 4, 5 7, 8, 9, 10, 11. Yeah, the classic Elise Roger comes in. Well, it's going to be the same thing. Elise Roger has 11 letters in the name, and 11, and so Elise Roger is going to be here too. So now we need to put Elise Roger here. And that is what we call a collision, okay? And how do we deal with collisions in hashing is always a big question, okay? How do we deal with these collisions? Well, one way we can deal with collisions, and kind of the fun way we deal with collisions, is to use an idea called chaining, okay? And in chaining, what we basically do is you hash to here, and what this is it's a head pointer to its own linked list. Okay, and so it's a head pointer, so it's this head pointer to its own linked list, okay, where the first element will be Sandy Newman's records, so SN's records, okay, and then its next pointer will point to Elise's records, okay, and then in this situation, I guess Elise would point to null, but if another person came in and we wanted to insert them there, we would hash to 1, right? We would go all the way to the end, okay, which we know how to do, and then we would insert that record there, okay? And so that's pretty nifty, right? It uses linked lists and the idea of hashing together. And that's kind of the coolest one. There's a few other schemes we will go into in the next videos, but we'll ask you a few questions about chaining in the meanwhile.